All right, so this is a week 2, day 2. Actually, I should be calling this week 3, day 2, right? But because this we already did the chapter 8 stuff. But I guess week 2, day 2, polynomial review. So basically, addition or subtraction. Maybe what I'll do is I'll do a subtraction problem. I may change that plus in the middle to a minus just to make it a little bit more interesting. But it's addition and subtraction of polynomials, expansion of polynomials like this. Like how do you rewrite that to expand it? And then factoring factoring differences of squares. Okay, and that's it. It's just these types. Okay, so factoring differences of squares, expanding and adding and subtracting. So let me change this really quick. I'm gonna make it a minus instead, if you guys don't mind. Okay, because the plus isn't that hard. You just don't change any signs. Okay, you just rewrite it. Don't change any signs. When there's a minus there, it's a little bit more difficult because you got to distribute those signs. Okay, so this is what it's going to look like when you're trying to simplify this expression. By the way, you're going to notice it's going to say number 1, number 3, number 5, right? This is number 7 because that's what it is on your homework. So I'm just trying to, well, actually this one may not match, but it was supposed to match. But that's what the numbers on the side are going to be. So your number 1 is going to be off because I'm changing it to a minus. Okay, I'm sorry about that. But we're going to distribute, okay? Don't forget to do that. So you're going to get n squared minus 7n minus 7n to the 4th minus 2n minus 4n to the 4th minus 5n squared, okay? So you're going to distribute. That's the hard part to that problem. After that, the rest is supposed to be simple. Get your common terms, put them together. Okay, I always start with the highest power. So I'll start off with negative 7n to the 4th minus 4n to the 4th. Well, that's going to be negative 11n to the 4th. So negative 11n to the 4th. I'll cross these out. Then I'll go to the next highest power. That's n squared minus 5n squared. That's negative 4n squared. I'll get rid of these. And then the last two that are left are like terms. Negative 7n minus 2n. That's negative 9n. And I'm done. Okay. So remember, guys, it was supposed to be number 1 from your homework, but it's not because I changed it. So don't copy this answer on number 1 from your homework or else it's going to be wrong. Okay. You're going to have to do the addition portion yourself. Okay, but that's easier. Addition, nothing changes on the signs, just kind of rewrite it and combine terms. So it's actually less work. Okay, so you're going to have a couple questions like that, which should not be like, oh my gosh, these are so difficult, right? You're going to have a couple questions like this where they say find the product. The number 1 mistake that happens with these problems is that people write this. Now, don't write this down, but people will write this. Okay? And that's completely wrong because they're like, well, wait a minute. You said that if there was things in a parenthesis and a power on the outside, I can just distribute it. Yeah, if it's multiplication or division, addition or subtraction, you can't do that. Okay, so this would not be good. What we need to do is we need to expand it. So x plus 4 quantity squared means that you have to write it down twice. Okay. I mean, you can also do it in your head if you're really good at expanding perfect squares. But I never really do that. You guys should know that by now, right? I always take the long road because there's some of us here that can expand this and you can write x squared plus 8x plus 16 and you're done. Like you got it in your head, you got the answer. But there's some people here that don't do that, right? Not everybody has the same math mind. So that's why I always kind of show the whole steps, right? Because I don't know who needs it, who doesn't. So let's just better treat it like everybody needs it. So we're going to distribute this thing, okay? So we have x times x and x times 4. So that's going to be x squared plus 4x. And then we're going to get 4 times x and 4 times 4. That's 4x plus 16. Okay? Now, there is no x squared term other than the first one. So I'm not going to be able to combine it with anything else. But the 4x plus the 4x, that's 8x. Okay? And then the plus 16 at the end. And we're done. You'll notice I'm not taking as much time going through this because we by now should be really good at this, okay? Hopefully. So I'm just kind of going through it. Now, again, you're going to have a couple problems like that where you're just going to have to expand them. After you expand them, just simplify them and you're done. So nothing I don't think anything to really worry about. I think this is a pretty easy assignment. Okay, this one might trip some people up, but it really shouldn't, but it could. Okay, I do want to remind you guys, differences of squares are supposed to be rewritten like this, and then you're just supposed to factor it like this. So once you know what your A and your B terms are, you put them there, and you write them out as two factors. Okay, so that's basically like your formula. Okay, now for us, I have 4x squared minus 9x squared. So I have to ask myself, what squared is 4x squared? Well, 2 what? 2x. What squared is 9y squared? 3y. So once I have that done, then all I have to write is just 2x minus 3y, 2x plus 3y. It's really pretty simple. The hard part is having to figure out what you put inside those little parentheses, right? What squared becomes the 4x squared? What squared becomes the 9y squared? Here you do distribute the powers. Why? Because this is multiplication, right? For 3y, 3 times y to the power of 2 becomes, bless you, 9y squared. 2x squared becomes 4x squared, right? So in that point, you can distribute the power because it's not addition, it's not subtraction, it's multiplication. All right, so one more of these. This is question number 7 for you guys. Now, this one's a kind of like a trick question, but not really, because what you're supposed to do is say, okay, what squared is 5a squared? Well, what squared is 5? Well, the square root of 5 squared is 5, but we don't do that, right? So that means that maybe I got to mess with the equation, really, or the expression. So I notice 5 and 45, they both have a 5 in common. So let me take out a 5 first, okay? And I'm going to write a squared minus 9b squared. And now I'm just going to focus on this part right here. So what squared is a squared? Just a. Minus what squared is 9b squared? 3b. Now I still have this 5. Okay, let me highlight it. Remember how I used to do it when we taught this the first time? I'm going to highlight it so I don't forget, because it's going to be part of my answer. Okay, so this is going to be a minus 3b, a plus 3b, and then this 5 is going to show up right there. Okay, so don't forget about that kind of hanging 5, the one that you had to factor out. So when you're doing these problems, when they're perfect squares, you right away ask yourself, what squared is this? What squared is that? Okay, and if it works, great. You write out your factor and you're done. If it doesn't work, then you have to ask yourself, can I factor something out? If you can, then do it. If you can't, then that just means it's not factorable. Okay, so if I would have not been able to factor out a 5, then I'd be done. Okay, in other words, like let's say this was like this, 5a squared minus 7b squared. If that was the problem, then I would basically say this is my answer, because I can't factor this out using a difference of 2 squares. Nothing squared is 5, bless you, nothing squared is 7. I can't take out a 5 or a 7. There's nothing I can take out. So basically I'm stuck. So that would be my answer. Okay, we call that prime. I don't know. Do you guys ever remember hearing that word? Not prime numbers, but when they tell you to factor it and you say, well, I can't, so we call it prime. So that's what we call it now. We don't teach that anymore in high school, but I know in elementary school sometimes they still, not elementary, middle school, they might still do that. So anyway, let me go ahead and stop this. Just a 10-minute or 9-minute lesson. So let me give you the homework.